Here's a past paper problem on velocity time graphs. We've got a vehicle moving along a straight horizontal road. At time 0 seconds, the vehicle passes a point A and it's moving with a speed of 20 meters per second. It continues moving at a constant speed for 8 seconds, and then the vehicle slows down with uniform deceleration for 10 seconds, so that at 18 seconds in, the speed of the vehicle is 6 meters per second, and then this speed is maintained until the vehicle reaches the point B 40 seconds in. We've got 3 things to do. In part A, we need to sketch a velocity time graph describing this motion. In part B, we need to find out what the deceleration was. And in part C, we need to calculate the distance travelled. Now, it's worth 9 marks in total, so you want to spend around 8, 9, 10 minutes, something like that. And when you're trying to break down this information, it might be worth using a highlighter to sort of emphasize the different sections of the journey. Pause the video, give it a try, and when you're ready to have a look at the answers, unpause it and we'll work through it. Okay, let's try and draw this velocity time graph then. So there's 3 sections to the journey. The first part, where the vehicle sort of starts its journey, it passes through A. It starts with a velocity of 20 meters per second and it maintains that for a little while. It's got a constant speed of 20 meters per second for 8 seconds. So the first leg of my journey should just be a straight horizontal line, and I'm going to label the vertical with 20. I'm going to label the horizontal with 8. I'm just going to draw like a little dotted line going down. Got 8 seconds there. The next part of the journey, it tells us that the vehicle slows down with uniform deceleration. That just means that when I draw the curve coming down, it's going to be a straight line. That's going to last 10 seconds. It's going to take me into 18 seconds in, and the speed of the vehicle is going to go down to 6. So I'm going to draw another straight line. This doesn't need to be to scale or anything like that. That's not a problem. So I'm going to draw a line coming down like this. So we're going to be up to 18 seconds in, and we're going to be down to a speed of 6 meters per second. And then after that, this speed is maintained, so it goes back to moving at a constant velocity until the 40-second mark. So our velocity time graph, and as I said, it is a sketch. It doesn't have to be particularly accurate here. I know that my scale isn't great, but it should have this sort of general shape. Now, with regards to the other parts, in part B, we need to find the magnitude of the deceleration. So basically, the rate of deceleration. The magnitude just means the size of it. So we don't have to worry about that. We can ignore the fact it's decelerating. Actually, we don't have to include the minus that we would get from it slowing down. So the acceleration formula is the change of velocity over time. And in this period here, we've gone from a velocity of 20 to a velocity of 6. And we've got a time period of 10 seconds. This is going to work out as minus 14 over 10, which is minus 1.4. The unit for acceleration is meters per second squared. And because it said the magnitude of deceleration, I can ignore the minus sign. Magnitude of the deceleration is 1.4. Okay, cool. For part C, I need to find the distance AB, and this can be done by finding the area under the curve. So what I'm going to do is I'm going to work out 3 regions. I'm going to find the area of this rectangle, this trapezium, and this rectangle. So initially we've got A rectangle with base 8 and height 20 gives us a value of 160. That rectangle there represents 160 meters traveled. This trapezium here, the formula for trapezium is a half a plus b. A and b are the parallel sides. So what we've got 20 and 6. And the base of the trapezium, 8 to 18, that's a change of 10. So I've got a half times 26 times 10. And I can do this without the calculator. I should be all right, which is going to work out as 130 meters traveled. The last section of my journey is another rectangle. The base of the rectangle goes from 18 to 40, so it's 22 units long. And the height of the rectangle is 6. 22 times 6 is 132. So I'm going to take those three values and add them together. And we can just slam them in on the calculator. That will be absolutely fine. And if we work it out this way, we are going to get 422 meters traveled.